Good day, wonderful, welcome. Here we can study about infrared spectroscopy and how to interpret the IR spectroscopy results. What is IR spectroscopy and why to understand its results? If anyone wants to analyze the functional group of unknown compound and synthesize molecule from a chemical reaction, understanding the IR spectroscopy is important. For example, the molecular formula of C4H8O can give many possible isomers of molecules. The two possible molecules are alcohol and a ketone. The mass spectrometer cannot differentiate between those molecules. Moreover, it will give the molecular peak at 72.1 for both the molecules. But the IR spectroscopy can jump in to indicate and differentiate the presence of alcohol and ketone. Understanding of IR graph is very important, which we are going to see here. The principle of the IR spectroscopy is based on Hooke's law with the bond vibration in the molecule. The bond vibration as well as various types of vibration like bending, asymmetric and symmetric vibration causes to absorb the IR frequency. Moreover, the bond stretch could also increase the amplitude of the spectrum. The representative cartoon indicates IR spectrometry where the IR light passes through the sample. The IR frequency is absorbed based on the various type of vibration of the molecule. The remaining light passes through the detector. Finally, spectrum results indicating the amount of transmitted light versus its frequency. The frequency always indicated in the wave numbers. The wave number starts from 4000 to 400 in the IR spectrum. The sample with covalent bonds to hydrogen vibrates more because the hydrogen is lighter. The bond vibration from carbon to hydrogen, nitrogen to hydrogen, oxygen to hydrogen falls on 4000 to 2500 wave numbers. The triple bonds from carbon to carbon, nitrogen to carbon fall in the region of 2500 to 2000 wave numbers. Double bonds like carbon to carbon, nitrogen to carbon and oxygen to carbon fall between 2000 to 1500 wave numbers. The wave numbers from 1500 to 400 is called fingerprint region. It indicates the single bond of carbon to carbon, nitrogen to carbon, oxygen to carbon, and halogens to carbon. People may ignore this region because the NMR results can jump into this place and calculate about this information. Let us look at the various functional groups present in the molecules from the IR spectrum. The molecule which has the bond polarity is very important for the IR spectroscopy. Anything with strong dipole moment. For example, carbon double bond with oxygen as well as carbon single bond with oxygen. Similarly, carbon single bond with hydrogen can give strong signal. The molecule does not have the bond polarity. For example, the internal alkene of carbon to carbon double bond. Similarly, internal alkene of carbon to carbon triple bond cannot be detected by IR. Let us see the general functional groups of IR spectrum, but not any conjugation and not any other species. Identifications of alkanes, alkenes and alkene are shown here. For alkanes, example, pentane. The H bond with carbon falls between 3000 to 2800 wave numbers. The alkenes. Example 1 hexane. The H bond with sp2 hybridization carbon falls between 3100 to 3000 wave numbers. And the H bond with sp3 hybridization carbon falls between 3000 wave numbers. Double bond from carbon to carbon falls on 1650 wave number. The alkene, example 1 pentyne. The H bond with sp hybridization carbon fall on 3300, and the H bond with sp3 hybridization carbon falls between 3000 wave numbers. And lastly, the CC triple bond falls around 2250 wave number. The oxygen-containing functional group of compounds of alcohol and ether of IR spectrum comes next. The identification of OH from the alcohol group falls on 3200 to 3600 wave number. For example, 3BUTENE2OL indicates the OH fall between on 3200 to 3600. An H bond with sp2 carbon falls between 3100 to 3000 wave numbers, and the H bond with sp3 carbon falls around 3000 wave numbers. Double bond from carbon to carbon falls around 1650 wave number. Identification of ether group, for example, diethyl ether shows bond from carbon to hydrogen at 3000. And bond carbon to oxygen falls on 1100 wave number. Let us look at the identification of oxygen-containing carbonyl compounds of aldehyde ketone, carboxylic acid. For aldehyde group example hexanyl, the identification of C double bond with O of carbonyl falls between 1690 to 1740. And the H bond with C falls around 3000 wave numbers. Identification of ketone group is the spectrum of 1680 to 1750 wave numbers. For example, 2-butanone shows that the double bond from carbon to oxygen falls on 1700 wave number, and the bond from carbon to hydrogen fall on 3000 wave number. Identification of carboxylic acids group is the spectrum of 3500 to 2500 wave number. For example, propiolic acid, the carbonyl group fall on 1725 to 1700 wave number, and the CC triple bond falls around 2100 wave number. Let us look at the identification of nitrogen-containing functional group of compounds. Identification of amino group is the spectrum of 3300 to 1350 wave numbers. For example, propylamine shows that the NH bonds and the bond from carbon to hydrogen fall on 3000 wave number. Identification of amides, 3300 to 1350 wave numbers. For example, propanamide shows that the NH bonds and the double bond of carbonyl group from C to O fall around 1600 wave number. Identification of nitriles falls on 2220 to 2260 wave numbers. For example, propionitrile shows that the triple bond from nitrogen to carbon in this region, and the H bond with C falls around 3000 wave numbers. Lastly, let us look at the results from mass spectrometry in IR from the unknown compound, and try to find out the molecular formula. Calculating the possible molecular formula from the unknown compound. The mass spectrometer result is indicating the molecular ion peak at 58. Calculation of possible number of carbon from the mass spectrometry result of molecular weight 58. The 58 divided by 12 gives 4 carbons 9 hydrogen. Remove some of the hydrogen and carbon, which is equal to 1 oxygen, which is 1 carbon with 4 hydrogen. The unknown compound has possibility of C3H5O. Calculating the molecular weight of C3H5O is 57, but the mass spectrometer results indicate 58. And it is good to add hydrogen to make it C3H6O, which matches the molecular weight 58 of mass spectroscopy result. Calculate the degree of unsaturation by number of saturated hydrogen minus number of actual hydrogen, divided by 2, which gives 1. 1 degree of unsaturation gives the information either it formed a double bond or a ring. The 4 possible structures were created with C3H6O. Let us match the functional group of IR spectroscopy results with the 4 molecules. The IR results indicating the O stretch around 3200 to 3600 wave number, and the double bond from carbon to carbon falls around 1650 wave number, and the hydrogen bond with carbon falls on 3000 wave numbers. The IR is matching with allyl alcohol.